Okay, so this is the rest of Activity 10 practice. It's on page 130, and it's the lesson 10-2 part of the practice. So 12 through 15 say solve for x. So we are just going to follow our step chart that we made in class. Step 1 says check for distribution, and in number 12 there is none. Step 2 says collect like terms on each side of the equal sign, and they're already collected. So now we're on step 3, which says get all the x's on one side by using addition or subtraction. So I'm looking here and I see 0.15 is bigger than 0.1x. These are both x's, so I'm going to go ahead and subtract off the 0.1x from both sides. That'll just give me 6 on this side. Excuse me. And then 0.005x on this side. And then I'm going to go ahead and get my numbers on the other side. So subtract x. And this gives me -2. So then I'm just going to jump on my calculator real quick and divide both sides by 0.05 to give me x equals. So -2 divided by, oops, I forgot this is my husband's calculator. Let's just do 2 divided by, excuse me, one more time. 2 divided by 0.05 equals 40, and I know that's going to be a -40 because negative divided by a positive is a negative. And I am correct. So I would go ahead and check my work by putting a -40 in for both those x's and make sure they come out correctly. Okay, so down here I have the same situation where there is no distribution. My like terms are already collected on both sides. 0.3 is smaller than 0.8, so I'm going to subtract 0.3x from both sides to get my x's on one side of the equation. And that will give me 41 over here and 0.5x minus 11 on this side. Now I have to get my numbers on the opposite side. So I'm going to add 11 because it's the opposite of subtraction. 0.5x equals, and 11 plus 41 is 52. And then I'm going to go ahead and get my calculator out again and see what I get. Since there is decimals in my problem, I can have decimals in my answer. So that's 52 divided by 0.5, 104. That's my final answer there. Okay, 14. Now my first step says to use the distributive property if I can, and these parentheses times -2 suggests that I have to do that first. So on this side I'm just going to rewrite my expression on the left. On the right I have -2 times x. -2 times -2 is +4, and then bring down the +3. The second step says to collect like terms on both sides of the equation. So I have a -10x and a +8x. That gives me -2x. Then I have just +3 is going to come down. Here I don't have any other x's, but I do have regular numbers here. 4 and 3 together makes 7. So everything's collected now. I'm going to get my x's on one side. So I'm going to add 2x to both sides. This gives me 0, which is 3. This gives me 0 as well, which is 7. This is not true. This is not a true statement. 3 does not equal 7, right? So there is no solution to this problem. All right, and now I'm on problem 15, and I have distribution happening on both sides. So I'm going to distribute the 2 to the x and the -11, and then the 6 to the x and the +3. And then I need to get all my variables on one side, which I'm still choosing the larger one, so I don't have a -x. And then I have to get my numbers on the other side. So that gives me 4x. And then -22 and -18 together is going to be a -40. and then divide both sides by 4. So x equals negative 10. All right, so now we're on 16. And 16 says, which of the following could be the first step when solving the equation 5 plus 6 times x minus 1 equals 11 plus 5x. So the first step, A, says to multiply the x minus 1 by 6. Well, that looks like I would go with that choice. B says subtract 1 from both sides. Well, there isn't any 1's being added, so that's definitely not going to be one of my choices. C says divide by 5 on both sides. Well, divide by 5, this is being really added. It's positive, so that's out. D says subtract 5x from 6 times x minus 1. Well, that's impossible because you don't have like terms yet, so that one's out. So the answer here is going to be A. And 17 just says to solve. Now, it's quite a big equation here, but I think if you'll listen to what we're doing, we know all the steps. The same 6 steps, the same 6 steps apply, right? We've not done the 6th step every time because you're just trusting that I don't need to check my work, but you do need to check your work. So I can't stress that enough. The only reason why I'm not doing every single check is because I have the answer key and I've already worked the problems. But you don't have the answer key and you have not already answered the problems. So, you know, as a student, I would be checking this every single time. Okay, so first step, the distributive property, right off the bat. Okay, that's 3 times x, 3 times 1, and then bring everything else down on that side of the equation. On this side, I again have the distributive property. Now I have a 2 in front of this x, so I don't want you to be thrown off. It's still happening that it's 2 times 2x, which is 4x. 2 times 2 is 4. And then I'm going to bring down my plus x here. So that wasn't so bad. My second step says to collect like terms on each side of the equation. Well, here I have x's that look like I have 5x altogether. And here I have 3 and a 1, which is like plus 4. So I had 2 things to collect on the left, but they were totally doable. On this side I have a 4x and a 1x. That gives me 5x. And then I have this plus 4 that nothing is combined to. Well, I'm starting to notice that my equations are the same. But the next step is to get my variables on the same side, which I end up with just 4 equals 4, which is true, right? So this is all real numbers. You could also write that as double bar R. You could also write that as infinitely many solutions. So we have 3 different ways we can write that. Okay. 18 says, what is the next step in solving the equation? So I hope you can realize a fraction out in front being multiplied really means multiply by the reciprocal. So if I were going to solve this, if I didn't know that this was a multiple choice, I know my first step is going to be to do 5 over 4. And I wrote 5 over 5 on this side, but I meant 5 over 4, which is just taking that fraction and flipping it over. So let's see if that's one of our choices. A says to subtract 4/5 from both sides, which we cannot do because it's being multiplied. That is not an inverse operation. B says to multiply by 5/4 on both sides, so I'm already rooting for B here. C says to subtract 5 minus 4. Again, there's no addition subtraction happening to x, so that is not an inverse operation. And D says to subtract 4 times 5, which is, again, we aren't subtracting because there is no addition happening. So B is going to be my choice. Okay, so number 19 says, which equation is not equivalent to 6x minus 1 equals 11 plus 5x? So there's no distribution happening. Like terms are already collected on both sides of the equal sign. So I'm going to go ahead and subtract 5x from both sides, which will give me 11. And 6 minus 5 is just 1x minus 1. And then I'm going to add 1 to both sides. So that goes away. That gives me x equals 12. So now if I plug that back in, I just want to be sure I have the right number because I'm going to check all these other equations and I need to make sure I'm right. So 6 times 12, what is 6 times 12? 72. 72 minus 1 is 71. Over here, 5 times 12 is 60. So 60 plus 11 is also 71. So my work checks out. This says x equals 12. That is the same. It says which one is not the same. If I add 1 to both sides, this gives me x equals 12. So that is not it. Here I've got 10 over 6. 10 over 6. So this all cancels out. This gives me, canceling, 3 goes into 3 once, 3 goes into 6 twice. So 10 divided by 2 is only 5. Okay, D looks like our best choice here. So now let's check this one. If I subtract 5x from both sides, it gives me x equals 12. So D is my answer because when I solve all those equations, I get x equals 5 for D and x equals 12 for everything else. Okay, so now we're on number 20, which says which choice is a solution for the equation 7x plus 11 equals 10x minus 25. So basically I just need to solve this. So first step, there is no distributive property. Like terms are already done on both sides, so now I need to subtract x, get my x's on the same side, which gives me 11 equals 3x minus 25, and then get my numbers on the opposite side. So this is 3x equals, this is 36. Divide both sides by 3 because 3 times x, I have to do the inverse operation, which means x is 12. So I'm going to go back to my 20 and it looks like that answer is C. 21 says solve for x. So again, there's no distributive property. Like terms are already collected. I'm going to subtract x from both sides to give me just 1x plus 1, and then my numbers on the other side. X equals 2. There's nothing to divide by or multiply by on that last step. So 2 looks like my right answer, but I'm going to go ahead and double check. I'm going to show my check step on this one just so you can see it. If I put 2 back in for x, this side 2 minus 3 is negative 1. Uh-oh, I must have done something wrong. So 2 times 2 is 4, plus 1 is 5, so it doesn't check. So I need to figure out where my mistake is. 2x minus 1x is 1x plus 1. If I subtract that, oh, negative 3 right here. There's where my mistake is. See why the check step is so important? This would make negative 3. I forgot to bring down the sign right in front of it. So if I subtract 1, that gives me negative 4. So my check step proved to be very helpful. So I'm going to go back over here, and everywhere there was an x, I'm going to put in negative 4. Negative 4 times 2 is negative 8, plus 1 is negative 7, and right here negative 7. Negative 4 minus 3 is negative 7. So, phew, good thing I checked my work. Number 22 says, why is it important to be able to use the properties of numbers and equality when solving an equation? So you would put this in your own words, but basically properties of numbers and equality are used to simplify the equation. You need to make sure that each simplified statement of your equation is true. So equations involve two sides that have to remain equal, so you have to use these properties of equality to maintain your balance. Remember, we talked about a scale. The the properties of equality just ensure that you are performing the same operation to both sides so that it always stays true, because otherwise you're making the equation different. So I know I didn't write all that out, but you would put that in your own words. And that's all I have for 10-2. This is the rest of activity 10 practice on page 130, and I will see you in class.